Welcome to our Masters of Engineering capstone presentation. We are Team Omnica, and we will be presenting a traumatic brain injury assessment system.
My name is Arturo Arteaga, and I'm the team lead, and I'm in charge of project management.
My name is Luke Pierce, and I'm in charge of SolidWorks design.
My name is Josh Wang, and I was in charge of 3D printing and prototyping.
My name is Mark Risco. I'm the Team EECS lead, and I was in charge of design and wireless communication.
I'm Hao Yuxie. I'm in charge of the GUI and battery.
I'm Zonghong Su, and I'm in charge of the Arduino code and the system assembly.
The biggest problem is that 1.7 to 3 million concussions occur yearly. 50% of these concussions are going undetected, which leads to second impact syndrome, which can lead to fatality in most cases.
Our goal is to create a simple-to-use, low-cost, and reliable concussion detection system that alerts a user in real time of an event that has the potential to cause a traumatic brain injury.
Here we have the system design and the execution flow. On this side we have the helmet, and on this side we have the receiver with the Bluetooth table. Here is the flow chart of the execution. First we initialize the sensors. That'll be the accelerometer and the gyroscope here on the helmet. After we initialize the sensors, we then initialize the Bluetooth, which is located on the microcontroller. Once everything is initialized, we can begin sensing impacts. Once we sense our first impact, we test it above the minimum threshold. If it's not above the minimum threshold, then we keep going back and we sense the impacts again. If it is above the minimum threshold, then we log and record the impact, and then we test whether the impact is concussive or non-concussive using our maximum threshold. If it is concussive, then we set the concussive flag to true, otherwise we set it to false, and then we update the BLE table located here. After we update the BLE table, the results will be available to show on the app, and then we go back to our loop of sensing impacts. Once everything is finished, then we can conclude our activity and end the process. Thank you.
So there are three components in our prototype. This is our microcontroller, and we're using Redboard Artemis, and it has a Bluetooth module in it right here. And this is our accelerometer, and we're using ADXL375. And this is our gyroscope, and we're using ISM330. And between the components, we're using Quick Connector. The Quick Connector is using I2C protocol, but it has a more stable connection and it's less prone to error. And the battery, we simply plug it into our microcontroller, and it can power our whole system.
Here's our test setup from the Impact Lab at CSU Long Beach, and you can see the 7-kilogram mass impacting the helmet in super slow motion. Next is a brief video showing the team's setup with a tennis ball launcher. The POV angle of the camera shows the ball launcher 66 inches from the helmet. The helmet was affixed to a mannequin head, and the whole head is braced to prevent from tipping. That was a 60 mile/hour impact to the side of the helmet. And now we're in the app view. First, we connect to the device. And once we've connected, we begin looking at the values in the Bluetooth table. First, starting with the unique ID of the device, which is arbitrary for now. Next, we look at the true-false variable to determine if we have a concussive impact or not. And finally, we looked at the raw acceleration value in G's.
In the first 5 weeks of our project, we completed our requirements document and finalized our Gantt chart. In weeks 6 through 10, we created a fully functioning prototype. In weeks 11 through 15, we created a phone-based app for an alert system and implemented the battery and gyroscope. In weeks 16 through 18, we conducted testing and completed data collection. And in weeks 19 and 20, we finalized data to ensure accuracy and precision of our device.
We did have some challenges for this project, the first of which was long supplier lead times. Our solution was to find suitable replacement components that met our requirements document. Another challenge was finding a suitable testing setup. We explored outside testing vendors. However, due to their long lead times and unavailability, our solution was to collaborate with Cal State Long Beach, and as well as our own DIY testing setup.
We'd like to thank the following individuals for making our project possible. A special thank you goes out to Dr. William Tang, Dr. Gisela Lin, and Dr. Farzad Ahmadkinlu, all from UCI. Also to Dr. Brad Sargent from Omnica Corporation, and Dr. Daniel Whistler from Cal State Long Beach. Thank you all very much.